Good morning, good afternoon, good evening, whoever you are, wherever you're from. Welcome back to Artisan Electrics, and today we're going to be fitting this Tesla wall connector. As you know, I love the Zappi chargers. They are my go-to charger, but I have so many customers asking me, can you fit a Tesla wall connector for me? And I always I have a few issues with the Tesla wall connector because of its lack of safety features built in. So what I wanted to do is do a video about all that's involved in safely fitting a Tesla wall connector, and then I'm going to just try it for a few weeks myself to charge up my Tesla here. I'm just going to give it a go and see if there are actually any benefits to having a Tesla wall connector over a Zappi. So as always, hit a thumbs up if you like my videos. Thanks to the thumbs up squad who always do that. And don't forget to subscribe if you haven't done so already. And let's get into the video. So it's a nice looking charger. And you can only buy one of these if you have got a Tesla. So you have to request them via email from Tesla. And you have to send them your registration number for your car, and then they'll send you one of these. So about 450, 500 quid, I think. But there's a few issues with this. So the thing about the Tesla wall connector is it's a very basic charger. It has no smart, as in, it is smart as in it connects to your Tesla app, but it's not approved by the grant because it's not, as the government don't view it as a smart charger as such. It doesn't have any built-in RCD protection. It doesn't have any built-in pen fault detection. So that means that unless you're installing it on a TT system, you need to install either an earth electrode for the charger only, or you need to install a pen fault detection device. So what we're going to do today is we're going to be installing a pen fault detection device, and we're going to talk about the options that there are when it comes to those. Don't butcher the box.
Oh, sorry.
Because I'm probably going to rip this out again in a couple of weeks and sell it to someone.
Oh, sorry, that's why I asked if you wanted to keep it plastic.
Oh, sorry, I didn't. I wasn't concentrating. Don't worry, it's fine. We can still stick it on eBay with a butchered box, I'm sure. Yeah, let's talk about the pen fault detection devices and how we're going to install this. So at the moment, the Zappi is just on a cable going back to my consumer unit with an MCB, a miniature circuit breaker. The cable doesn't need RCD protection because it is clip direct steel wire armoured. But we don't need RCD protection because it's all built into the Zappi. However, the Tesla charger doesn't have any RCD protection built into it, which means that we need the equivalent of a Type B RCD to actually protect the car and the charger. So we have to fit that somewhere else. So what we're going to have to do is, back at the consumer unit, we're going to have to install an RCD and a pen fault detection device. Now we have this from Viridian EV. So this is our current setup. This is our MCB for our charger. But that is not adequate for us to just put the Tesla charger just on an MCB. We're going to need to install an additional device. So we've got this, which is a Type A RCD. It's got 6 milliamp DC protection on a little circuit board inside it as well, and it's got pen fault detection device all built into this one little consumer unit box. So this is one option. This is from Viridian EV, and this is something that I've newly discovered. I installed one last week for an Ohmi charger, and it was absolutely brilliant because it just looks like a normal consumer unit. So for example, here we could just pop that there, and actually we could just link it across from the distribution board, wire it all up without having to do much alterations to the existing cabling, and that will provide all the safety features that we need for this Tesla charger. The other option, can you go and get the Matti device? Right, so this is the Matti device. So as I said, we've got a Type B RCD here. We've got a 32 amp MCB. So essentially we could, if we wanted to, come straight off the main meter tails. You know, put a Henley block or whatever and then come straight into this. Take a feed in there, you've got your earth connection there, and then your neutral connection would go into the bottom of the RCD, and then you can basically feed your charger out of the other side of the contactor. And then this is the electronics that do the pen fault detection. But as far as I'm aware, this is only measuring voltage and not current. So it's only doing the voltage method of detecting whether there's a pen fault, and that is a little bit unreliable and subject to nuisance tripping if the voltage fluctuates under normal conditions. Whereas this Viridian one is a little bit more clever. It's got these CT coils here which are measuring current, so it has the current and voltage methods to detect whether there's a pen fault, and therefore it's less liable to nuisance tripping. So that's another reason why this is a little bit better. It's quite tight in here, obviously, as you can see, but basically you just take your feed in here to the bottom of this RCD. It feeds through the RCD out onto the circuit board with these little copper tails. Goes through the circuit board, and that does your 6 milliamp DC protection as well, because this is only a Type A RCD. So you need your 6 milliamp DC protection for your EV, and then it does your pen fault detection, and then exactly the same, you've got a contactor here which does CPC, line and neutral, and you just take your CPC, line and neutral out the bottom to go to your EV. So these devices both work in the same principle basically, but slightly differently, and in my opinion this one looks a lot nicer and it's going to be more practical to install. This is actually an IP65 consumer unit as well, so you could, if you wanted to, install this outside. Now in my opinion I would always prefer to install it inside if possible, but if you need to, if you absolutely need to, you could fit this outside. So that's quite a good little feature as well. And Viridian do them in IP30 and IP65 versions, so you can choose. They've got various setups for various different types of chargers. This is one for the Tesla charger, but they can do ones for all the various different chargers that you need. Yeah, so for example, the Ohmi charger that we fitted the other day, it has Type A RCD with 6 milliamp DC protection in it. So you don't actually need an RCD, all you need is a pen fault side of things for that charger. So that's why they supplied me with one that just had an isolator switch here and then the pen fault stuff, but it didn't have the 6 milliamp DC protection on the circuit board. It just had the pen fault detection. You can get them to do ones with an MCB here as well, for example. They can do they're quite flexible. They can sort of build them to order basically depending on your situation. So it's quite handy, quite good. And they can make a larger one as well. So we've got a job later on this week where we're going to be doing like an 8 module one, where it's going to have a few different things built into it too. Obviously this one doesn't have overcurrent protection in it, so you do need to have an MCB for the circuit that feeds into this to do your overcurrent protection, whereas this one does have an MCB, so that acts as the overcurrent protection. So like I say, you could run off the main tails for this if you wanted to, whereas this one you do need to fit a new circuit in the consumer unit to be able to run off. But you can get them to provide ones with like a double pole RCBO instead, rather than RCD, which does the overcurrent protection then as well. So then you could run it straight off the main tails.
Oh gosh, it's freezing.
It is getting pretty cold out here, so does that all make sense, Cory? Are you ready to have a go at installing this?
Yeah.
Yeah? Okay, let's do it. Right, so this is the pen fault detection device installed, and something to be careful of with this is to make sure that the earthing systems are separated so that the only earth that goes to the charger goes through this contactor. So that means that if the earth of the sheath of the armoured cable is earthed, then you've got to do something to separate it. So for example, if we were terminating the armoured cable directly into this box, we should not connect the armouring of the SWA cable to the internal earth on the SWA. Otherwise you'll end up, even if the contactor isolates the earth here, it'll still come through the main earth bar through onto the sheath of the cable and then across to the earth in the charger. So the whole idea behind this is that it needs to isolate all three conductors, the CPC, the line and the neutral, and you just need to make sure that you've not got any cross connections with the CPCs. But that's all good, that's all done, so we'll go out and connect the Tesla charger on the wall now. So one thing I always forget about with these Tesla chargers is that you need a 32mm compression gland. Or you need something like this, which is because the hole in the bottom of the Tesla charger is a 32mm threaded hole, so you basically need a series of reducers in order to terminate a normal steel wire armoured cable. So what we're going to do is just take this armoured gland off and put it into a compression gland, because the armouring is earthed from the other side and we want to actually separate the earthing so that there's no access at all from the outside to the PME earth from the house, the one that's not switched through the contactor. So that will be just a way to do that. So we'll put this on and then that will terminate into the bottom of the Tesla charger, which will just mount straight on the wall there. Right, so of course it's starting to rain, but we've got this on, so that's looking good. As the charger is here, and it's got a little screw under there that needs to be undone. Special set that has...
This is my set.
Oh, that's why.
Name on it.
But yours has got the... Okay,
yeah,
so
it's just a little hole in the middle.
Yeah, that's it. So you need one of those, and that's because these screws have the tiny little pin in them.
Security bit.
So that's quite important, and I must have a set somewhere because I managed to do a Tesla install before, but I don't know where mine have gone. So your set has that in it, and mine doesn't, even though they look pretty much identical, which is kind of weird.
I mean, to be fair, it's possible that I've nicked it off another set.
Or just nicked it off another electrician, probably.
Yeah, more likely,
The cool thing about the Tesla charger is it looks like an alien. It just literally looks like something,
Jones, you know,
something out of Alien.
They take the coffin off.
Oh yeah. Or you know what?
Alien tomb.
It reminds me of the aliens out of Independence Day. It looks like one of those.
What, they made of plastic with cables coming out of them?
Yeah, exactly. Haven't you seen those plastic aliens on Independence Day? The plastic cabley aliens. So here you've got your mains connections there. Now this Tesla charger can be used for 3-phase or single phase, but obviously it's just single phase today, so we'll be just using L1 and neutral. The tethered cable, everything's already connected. The earth terminal is a bit tricky, it's that one down there. But basically it's pretty easy to actually fit. And then one thing you do have to be careful about is making sure you click that in to the front plate, because you've got this little circuit board. And the other thing you need to be careful about is this rotary switch here. The rotary switch is automatically just set to 1, which will only allow you to charge at a very, very slow speed. So you have to set it to the correct setting. So at the moment it's set to 1, which is 6 amps. You have to actually ramp it up to whatever you want to limit the charger to. So in this case we'll put it up to 8, which is 32 amps. And just turn it up to number 8. Yep, brilliant. And then the dip switches are, what do they do again? Oh, it's just whether it's on a TN system or an IT system. So we're on a TN, so we want, yeah. I think anyway that just stays on the default setting. I can't remember exactly, but it's all in Chinese anyway, which is not very reassuring, is it? So the base plate is what you fix to the wall, and then that literally just clicks in, and there's a couple of screws that go in the sides to actually hold it onto the base plate. It's quite simple, and it's quite a nice solid base plate. But what you'll need to do is offer it up so that the charger is at the right height compared to the cable, and then you'll know what height to put your base plate at. Great. Real chunky tethered cable on it compared to the Zappi one.
Just about there.
Yeah. That height. Well, if you just do it, for example, to the top of that brick, of the bricks, and then centre of that cable, then that should be fine, shouldn't it? Cory's just noticed a very important point, which is that there are two big gaping holes in the back of this which you need to fit bungs in, and the bungs are supplied by Tesla. A gentle caress. That does look nice, I must admit.
Yeah,
It actually looks pretty cool. Yeah. Yep, so if you remove your lockout tag out and turn the power on, then we can try and pair it up to my app.
Oh, that's cool. Oh, that's so cool.
If I do charging, start charging, then you can see the voltage, and then it should just start ramping up from 0 to 32 amps. 1 amp. 7 amps. 14. 17. 18. 17. 14. 31. 32. There we go. That's it. It works.
Wow.
But that's it.
Where do you store the cable? Is it another wraparound?
Around it, yeah.
Plug it, there's no buttons pressed or anything.
Press the button and see if it stops charging. Yeah, okay, that's quite cool. So, and then, I know, press it again. And then try and pull it out. So just to show you the Viridian thing here, so that's all installed. We've got a type A RCD with 6 milliamp DC protection. That's all gone in quite neatly, and obviously that provides the protection that the Tesla charger needs. But again, if we weren't installing a Tesla, we didn't need that. You know, the My Energy Zappi has everything built in, so it's much better. Right, so we've ripped the Zappi out and we've put the Tesla charger in. How did the install go, Cory? What do you reckon?
Yeah, I mean, really easy to install. I'm not very impressed with it in terms of, compared to the Zappi, I don't think it really has a leg to stand on. Like in terms of actually installing it as well, this is much nicer to install. Like, it came with the nice screws with the rubber washers on, and the actual terminals, there's loads of space to get a nice swoop on it. In here, it just didn't seem very well designed. And the actual way the cable wraps up as well, obviously on this, you can wrap the cables up nicely and then give it a proper solid place to click into. On this, I mean, if that drops out, which it could quite easily, and snaps off the floor, that could crack the plug. I'm not massively impressed with this, but it's a nice looking charger until you wrap the cables onto it.
Yeah, so we said it looks cool. It looks like a bit of an alien on the wall. It does look futuristic, but it's not smart at all. So it doesn't connect. You can't connect it to anything with Wi-Fi. It's literally just you plug your Tesla in and then you do all the controls on the Tesla. So it's pretty dumb. There's no way of sort of monitoring your energy usage and things like that, except through the car, but not directly through the charger. There's no kind of solar input set up or anything like that.
Or grid demand, is there?
No grid limit, so it means that, you know, technically we could blow the main fuse if we're using loads of electricity in the house. So there's a lot of downsides to this, but I'm going to try it for a few weeks and see how it goes, and then we'll report back. But maybe we'll end up sticking the Zappi back in. I think I'm definitely going to put this in a safe place, that's for sure. So yeah, as always, thanks for watching. Stay tuned on the next one. Make sure you subscribe, and we'll see you on the next video. Thanks, and have a great day.